Hello! Maybe, I don't know. I may not be live, I don't know. I forgot to put in the Lemmy reminder. That's an absolute shame. Probably should have done that before. Sorry, things are, I had to jump on real quick. Don't think anyone's even in yet, so that's not a problem. I did forget to run this up here, so people probably don't even know this is going on. This is the secret stream, the lost one, the hidden one. None will know about this one. Yeah, whatever. It's a good way for me to prove that I am doing it, or just force myself to do this stuff. How is my stroke going? What? Yeah, you know what? Fine. Quite mean, honestly. I'm hurt. Sorry if anyone started chatting. I got two people in here. I'm very slow today. Hello, Sorbet. Sorry for missing the notification on Lemmy. Uh. Oh my lord, I'm an idiot. This is week 15. It's nice to see you, though. Glad you're here. Okay. Let's pop up YouTube in case more people wanting to watch Rust, in fact, get a dose of Rust. Look, we're slowly going to indoctrinate the children into our personal projects. Soon enough, Reddit will be empty of the children. They'll all be on Lemmy. Hell yeah. Okay. Right, this is going to be taking up quite a lot of time. 6 different questions, testing our knowledge of ownership. I'm excited to be embarrassed. The ownership inventory is a series of quizzes that test your understanding of ownership in real-world scenarios. These scenarios are inspired by common Stack Overflow questions about Rust. I like that. Alright, I'm just going to jump in. I hope that you're on the correct location, if you're wanting to take the quiz along with me. Right, so if you try to compile this program, which of the following best describes the compiler error you would get? We have find nth, which, yeah, I've semi-forgotten, but this takes in... What is this? God, I haven't looked at this since last week. What is this? Ord is a trait. Yep, so order and clone. This takes in any element that implements the order and trait, or clone traits. So any list of elements that have these traits. And also usize. Ah, thank you for the explanation. Thank you for confirming. Right, then it dot sorts. That sort just, I'm assuming, sorts it. It sorts in place, replacing LMs with a list that is completely sorted. Thus the order trait. Let t equal... Sorry, delay. Yeah. Never a word. It's good to confirm too, honestly. I do appreciate that. Return t.clone. And right. What is the issue? What is the compiler error? Yeah, so without looking at these things, we don't have any lifetimes. That's what we just learned. I'm guessing it's something to do with lifetimes. We bring in a reference here and output a type. We don't know if, well, output something which, I don't know if it is lifetimes actually, because there's only one element here. Right, so let's go through that thing. We give lms a lifetime of A, n size a lifetime of B, and the return a lifetime of A. Well, this isn't a reference. Huh. Right, the lifetime of T must outlive reference T. I guess because this may not be, because this is of any type, it may not be a reference from the original LMs. This would work fine, but I think this so far is a pretty good answer. Cannot move out of shared reference in expression. Reference LMs N. I don't see that being an issue. We are not taking a reference of. This is not shared, is it? I don't think that's an issue. But it just returns a clone of T. Oh, it returns a clone. That's no lifetime issues? But it may not know. Sure, yeah, but it doesn't actually know what's inside of here. Wasn't the issue originally that it can only really look at the, what is this called? You can only look at the first line, oh, this is original. You can only really look at this first. I can't remember what it's called. God, what is that called? It's a word that I use on a daily basis. Whatever. Okay, so let's assume no lifetime issues then. Cannot move out of a shared reference for clone. Clone does not need a shared reference. Cannot borrow LMs as mutable for sort. This is not mutable. LMs is not mutable. What does sort do? Sort is this sort is stable, does not reorder equal elements, and worst case when applicable, and it doesn't allocate auxiliary memory. Yeah, I think this may be it. I think this might be it. I'm personally thinking that cannot borrow LMs as mutable for sort, because you need a mutable reference in order to sort in place. You think it cannot borrow LMs? Oh, yes, I think so too. Yeah, I think that's the correct answer. I'm going to submit that. Right. Return the nth largest element in a slice. You find nth, order clone. Same deal here. You have lms.sort. Normally, if you... here's it. Yep, cannot borrow LMs as mutable. As it is behind a... I think that means that we're correct. Cannot borrow... Yeah, we got it. I love how they do this. They just give you the answer to the next one. It's either, you fucking idiot, or, wow, you actually got that one right. That's fantastic. Normally, if you compile this function, you get the following error. Assume the compiler did not reject this function, which, if any, of the following programs would 1. Ask the compiler, and 2. Probably cause undefined behavior if executed. Check each program that satisfies both criteria, or check none of these programs if none are satisfying. Right, so you're looking for something that the code here does in fact pass the compiler, but secondarily will cause an issue. Right, so we have right, so we are bringing in a reference which borrows. LMs is a borrowed, non-mutable reference. Okay, so let v equal vector. Here it is, just a regular vector. We then pass in a reference here. I believe that's just borrowing. We find the 0th position. And then we clone it. And then do nothing with it. And then we clone it and return it. We return a clone. Will that delete here? Will that delete here? That's a good question. Will that delete here? I don't think so. I really don't think it will delete here. My question is, if it is created here within this scope, will returning a cloned piece delete it at the end of original scope? I'm going to assume not, because that has nothing to do with this original error. However, this is a review of the entire project, so honestly, it could be that. Huh. I'm going to say that this is fine. I think this would pass the compiler fine. In and of itself. And then would it? Oh, your answers are in a different order. That's weird. Huh. Right, so for this one, though, I don't think this is going to be an issue. Unless this doesn't dereference afterwards. This is the final use of this, so, within this area, so that should patch ownership back to V. I think this is fine. Right, this one, however, let's look. Vector. Let n equal a reference here, and then we're utilizing n. Here will cause an issue. This will cause undefined behavior. Right, so the reason for this is that n is the 0th position here. It is a reference to something at the 0th position. Now, sort. Sort does not allocate any more memory, though. This sort is stable, does not reorder equal elements, and, yep, when applicable on... Right, what? Generally faster than sorting and doesn't allocate auxiliary memory. If it doesn't, the current algorithm is adaptive iterative merge sort inspired by tim sort. It is designed to be very fast in cases where the slice is nearly sorted, or consists of 2 or more sorted sequences concatenating one after another. It also it allocates temporary storage half the size of self. But for short slices, a non-allocating assertion sort is used instead. Okay, I do actually think this is going to cause an issue. I think this will cause an issue because V will be, the memory where V exists will be deleted with sort. It doesn't explicitly state this, but I do believe that to be what'll happen. At which point, if we try and use n, we have a use after free. So I believe this to be an issue. Secondarily, we just have V, which is a vector, and we are not utilizing it at all. Alright, so gaming the system, I do believe this may be an issue, but I don't know why. It's the usage here that makes me think it may be, because of the sort. But it shouldn't entirely be. You know what? I think this could be the only one. What about you, Sorbet? Do you think that anything else may cause an issue? I am very curious to see your answer here. I may have missed something. I think there's only one issue. Or you think there's only one issue. I was reading off of you. I agree, though. Alright, let's submit. Alright. Of the following fixes, highlighted in yellow, which fix best satisfies these 3 criteria? Passes the Rust compiler, keeps the intention, does not introduce unnecessary inefficiency. Right, so we have LMs and usize T, so we still bring in a reference here. We let a mutable LM rest. We create a new reference here. We then a new reference of vector with references to T, elms.iter.collect. So we iterate over this, returns an iterator, and collect it. Right, so this will go from the first to the end. Let's assume this goes in the correct order, inside of the sortable order, because it has an order thing. I believe that iter will as an iterator over the slice, collect, transforms an iterator into a collection. Collect can take any iterable and turn it to a relevant collection. This is one of the more powerful methods in the standard library used in all contexts. The basic pattern uses turn one collection to the other, call iter. Yeah, do a bunch of transforms, then collect. At the end of collect, you can also create an instance of type, strings. Does this order things? Does this order things at all? Who knows? I don't think this will work, however, honestly, because this is just a bunch of references. C. To elements, right? Uh, yeah, I think that this is the better one of them all. I think this is likely the best one because all it is bringing the mutable. I was just trying to read through this to understand what it does, but that would be my personal answer. I don't see any issue with this. Like, we don't want to return an actual reference, we want to return a clone. Do we? Do we want to return a clone? Wait. What's wrong? There is another reference to Ellen. Where? What do you mean? Inside of here? Fourth line. 1, 2, 3, 4. Clone? Are we talking here? There's another reference to Elms. Are you talking here? Because that's not a reference to Elms. That's a reference to the element in Elms, if this is this one? Yes, I think this is fine, and the reason is because this is just an item within the Elms. So this is a reference to the nth number within Elms. I believe. Wait, can we? Wait, there was some weird stuff around that, wasn't there? I think you might be right. Can we have a reference to something within a reference? I think that we can, but that restricts what we can do with the other things. Especially if we just clone it. I think that's fine, but that's a good thing to bring forward. Yeah, I believe there was something specific, some strange behavior that exists when we create a reference to something within a reference which we already have, which is mutable. I think that that is a thing. Huh. I still think this is the best. Let's just quickly look over this. This is just a bunch of stuff. I don't think that does what... I don't think this will return a correct copy. No, it definitely won't. I don't think that this will create a copy of it. That's just going to do some weird reference shit. I don't think this... Well, that will sort it, and this doesn't actually fix the issue at all. Even if it did, this is just a lot of trash to put in for something meaningless. This creates a new vector. This is the closest. This is the closest, because this will still take in a reference to it. It'll just clone it out. This is what I do if I was programming myself, because I take the memory hit in order to have a bit of a usability hit, since we don't need to actually mutate this. Why would we want to mutate this? That is an issue. What would they expect it to mutate? I disagree with the idea that find nth should mutate element, as it does with sort. I think this would be a bad idea. If we mutate this, somebody could use it later on. You pass in elements to get the fourth version of it, the fourth number of it, the fourth sorted variable of it, and then later on you don't think that it's just sorted it on you. I think this would be the best way to do it, honestly. No. I think that is the best way to do it. Why would you need to mutate elements in order to get this clone? I think I'm going to answer with this, and if it's not correct, I disagree with them. Because this mutates elements. I disagree with mutating elements in this position. I've said that like 4 times. You definitely don't want to do this. This is incredibly dumb. Don't do that. But I am going to answer with this, and that is my query submitted. Okay. Program 2. If you try to compile this program, which best describes the error you'll get, we have a struct called hackResult. It is a vector of usizes, scores which is a vector of usizes, and a curve which is an option of usizes. A possible value to curve all scores. Implement test results. Public function getCurve takes in self, a reference to self, outputs a reference to an option usize, optional usize, self.curve. Right, that just outputs self.curve, a reference to self.curve. I see no issue with this. That is fine. If there's a curve, then increment all scores by the curve. Right, so public apply curve takes an immutable self. That's fine, I believe. I think that's fine. If let some what? I didn't know there was an if let. What? I'll admit, I don't know what this does. Have I forgotten this? Have I forgotten this syntax? I did forget about if let, I'll admit. Right, so I'm assuming if let, it has to do, right, okay, so I'm assuming that if let will simply, if this is, I'm assuming that if this is okay, this is the okay result, that it will do the rest of it. If not, it will not do the rest of it. Equals self.getCurve. Alright, that's just what I'm going to assume. If there is a curve, do this. Self.getCurve. What? Okay, yeah, sure. I will have to go back to the syntax. Apologies for that. I did just, it exited my mind entirely. For score in self.scores.intermute. The value of score plus equals the value of curve. Okay. I'll admit, I don't entirely understand. I think I understand what this is doing, but my lack of familiarity may be getting in the way of me understanding what the issue is. I believe that the issue, however, is that we are currently right, so we are mutating this within a for loop. Score plus equals the usize of curve. For score in, I believe this is the issue? I believe the issue here is that I remember, if I'm correct, that we shouldn't be doing references inside of, we shouldn't be mutating within a for loop, so an iterator. That's the issue. That's the issue. Is defining a variable that is equal to some curve. Yeah? I really don't understand what this is. But I believe that what is happening here, what the issue is that we are mutating while we are iterating. We are going 1, 2, 3, 4, going across it, but we are changing it as we go. And that is not something that we should be doing? Am I correct on that? We are alterating the iterator. Let's see what the errors are. In apply curve, cannot borrow self. In apply curve, cannot borrow self as immutable or get curve. Why not? Why would we not be able to borrow as immutable? I don't think that's an issue. I don't think that's an issue at all. In apply curve, cannot borrow self.scores as mutable or iter mute. Self.scores, self is mutable, we have gotten this. It has been borrowed, and then it has no longer been borrowed, and thus is owned back by self. So I think that's also fine. In getCurve, cannot return a reference to a local variable self.curve. Oh, that might be the issue, actually. I believe there is another issue, but can you not do that? No. This is a usize, so it implements the copy trait. That's fine. In apply curve, score cannot be mutated. I think that is the issue. The value of score cannot be mutated because it is currently being iterated over. What we need to do is we need to get the amount that is there, iterate over that, and then alter it, because we can't alter something that we are currently iterating over. I believe this is the issue. Do you agree? Do you concur? Do you concur? I think that is the issue. It is defining a variable that is equal to some curve. Am I misunderstanding what you're saying is the question? Because I really don't fully remember this syntax. Yeah, it seems like it. I think so. Okay, I'm just going to answer with that and continue on. Question 5. Test results. Students, yeah, let's see what we're being asked. Normally, if you try to compile this function, the compiler returns the following error. Cannot borrow self.scores as mutable because it is also born as immutable. Oh, okay, I think that's a different error. Immutable borrow occurs here. Self.getCurve. Mutable borrow occurs here. I think I was wrong. Shame. Immutable borrow later used here. Assume that compiler did not reject this function. Which, if any, of the following programs would 1 pass and 2 cause undefined behavior? Huh. Right. That's a shame. Anyway, let mutable result equal test result scores, factor of 20, 50, 30. Curve is sum 10. Result.apply curve. Right, so let's run through this. Apply curve, mutable self is applied. If let sum curve equal self.getCurve, self.getCurve runs through. We get the curve. That's fine. It didn't state anything about that being an issue. So we get 10. Sum curve equals 10. So curve equals 10. For score in self.scores.itermute, the value within score plus equals the value in curve. So that would be 30, 60, 40. I see no issue with that at all. None at all. I see no issue. Memory-wise, yeah, that wouldn't change any memory. Right here we have the same thing. Afterwards, we let x equal a reference to the result, score is 0. Result.apply curve. And then print x. Right, so that'll equals 20, which will change to 30. Oh, okay, so this is something that it does not like. I know that. So we have a reference here. I don't think this will compile. Because we have a reference. Result is no longer owned because we have a reference underneath it. This will not compile because we can't borrow twice here? Was that the original issue? Huh. Mutable borrow occurs here. But then it ends. Mutable borrow occurs here. It returns. Does it return? Oh my lord, I see why. I see why now. Because this is a reference to this. This is not a clone. This is a reference. Okay, I think I see now what the main issue is, why it wouldn't compile originally. Because this is a reference, and I didn't catch that. So this is alive. So curve, self is still borrowed here. Self is still borrowed as long as curve is alive. When curve dies, I see. Okay. Now this is why I love Rust, because you could make a similar issue in... If one of these can fail, then you can make a similar issue in C, and it would just be like, yeah, it's fine, who cares? Right. So, would this cause an issue, though? X equals the result score is the 0th position. I don't think it will... Will this compile? I mean, if this is allowed to compile, I see no reason why this wouldn't. But I don't think it would cause an issue, even if X is used afterwards. X would just equal 30 now, so that would output 30. How about this one? Result of scores, outputs... I really just don't see any issues in this underlying. I really don't think that any satisfy. I believe that none of these programs satisfy the issues. The only one I think could, I don't think would compile. There's no memory changes. Nothing ever changes the memory location of anything. Only the value within that memory location gets changed. Using something afterwards is fine. Again, the only issue I could see is if this tells... then it wouldn't compile. Okay, I'm just going to say none of these programs fail. Of the following fixes highlighted in yellow, which fix best satisfies these 3 criteria? It passes the compiler, preserves the original intention, fix function does not introduce unnecessary inefficiency. I think I am going to have very few correct things. Oh, I think clone may be the best. As reference, no, I don't think. That would not compile. So this would not compile because this is a non-mutable iterator. As reference, I think is a little bit better, but I still don't think that would compile. Cloning it, score would equal... No, that's definitely not it, because you would be changing scores clone. The clone scores and not the original scores. This is no longer using the original sum thing. This is no longer... Oh, wait, what? What's wrong with this? If it's already an option, who cares? Yeah, if it's already an option, who cares? Maybe get self.curve immediately instead of the getter? Yeah. I think that's a really good point, yeah. I think you caught that before me, but I didn't, I wasn't looking at chat. I think that is the best solution, yes, because this will simply return the option, which I believe is clonable, instead of a reference to it. I think that's fine. Because that's clonable. An integer is clonable. If we're not directly referencing, I believe it'll clone anyway, and that's what we want. We want a clone. Right. Or a copy. Copy trait. Yeah, I don't know why we would use a getter here, honestly, Lamau. Well, if we wanted to change curve, the reason we would use a getter, that wouldn't be a mutable reference, though. Why would we ever... You're right. Because it's not a mutable reference, there's literally no reason to get the reference to that. In this specific case. Yeah, I think that's fine. 50%'s a pass. We passed. 50% is a pass. I'm proud. Right. We got the first one correct. Cannot borrow... Yeah, well, we knew that. That's incorrect. So, let's see the correct answers. None of these programs. The program is technically memory safe because slice sort is only capable of moving elements around, not freeing them. For instance, okay. Reference v0 is guaranteed to point to some number after calling find nth, even if it's not the original number. Okay, so that's fine. So, right, so sort does not allocate auxiliary memory. That is what it's saying. That is what this means. I thought that's what that meant, but some other text down here made me think something different. The original memory exists. So we have... God. We have... I don't know how to... Anyway, we have... I don't know if you can see my fingers. No, you cannot. Right, so we have 4 boxes, right? We have 2 separate boxes that we just hold. And we put stuff from the original box in the secondary boxes and just move them around from the secondary boxes back into the original boxes. The original boxes still exist and still house the numbers that they originally housed. And the labels to those boxes still point to a box that existed in that list originally. So there's no issue. It points to memory. It points to the same memory as always. Okay, that makes sense. I don't know if I explained it very well, but yeah, that does make sense. Alright, this program, let's just reread this. This program is technically memory safe because slice sort is only capable of moving elements around, not freeing them. For instance, reference... Thank you, Sorbet, I'm glad. Reference v0 is guaranteed to point to some number after calling nth number, even if it's not the original number. Note that find nth, reference v10, does not cause undefined behavior. Because Rust performs checks on array accesses, so evaluating this will panic. Oh, okay. Oh, did somebody try to get the 10th element? Does not cause on... Okay, yeah, fine. Right, this one we got incorrect. Did I answer that? Of the following fixes highlighted in yellow, which best satisfies this? Letting immutable elements dot element 2vec. I believe 2vec. Yeah, 2vec clones. I don't see the issue here. The best one was the weird one that I thought was messed up and just instantly decided to look away from it. A function like findNth is clearly intended to be a read-only function. Yes, i.e. to extract some property out of the input sequence. Any solution which mutates or drops the input therefore does not preserve the original function's intention. I completely agree. That's why I picked this one, because it mutates. Because it copies. Does it not copy? Of course I can't actually see this. Why can't I see this? This is the original size. Oh, that's so weird to look at. And it still looks weird. You think it turns elements into a mutable variable? Like it redefines it? Okay, perhaps. Yeah, 2vec would make it seem like... Yeah, I think you might be right. So I had the correct idea, I just didn't really understand what 2vecs did. I thought that would clone it. But this does, in a way, clone it. Any solution which mutates a drop, even if does not preserve the original function's intention, even if it's more efficient than creating an auxiliary vector. Creating a vec is preferable to creating a vec, or vec reference t is preferable to creating a vec t, since if t is large, then lms.2vec could be expensive. Oh! This is the issue. So we were correct. This does the same function, but is inefficient. However, if we knew that t had the trait copy, then 2vec would be a preferable option to reduce the number of pointer dereferences within lms.sort. Okay, so we were technically correct if we had specific input. This is a more generically correct way to do it, though. Right, so we are creating a new vector of type reference t, whereas this would just be a vector of any type. This is a vector of references to original types. We have elms.iter.collect, which will apparently clone it too. Apparently. We'll just accept that. I don't see why in naming scheme it would, but we'll just accept that does. That's good. We then sort it, get the nth element, and then return a clone of it. Okay, that makes sense. So both are solutions that would work, but this is inefficient in the vast majority of cases. Or, well, in larger amounts of cases. Good to know. Right, we got this one wrong. We knew that. In apply curve, cannot borrow self.scores is mutable for iter mute. That was the issue. This one I wasn't certain on why exactly. I'm really curious to see the answer here. Due to lifetime elision, I hate that. The function getCurve has the type signature getCurve lifetime a reference lifetime a self outputting res. This means that a call to self.getCurve extends the entire borrow on self, not just on self.curve. Therefore, self is immutably borrowed inside the scope of let sum curve equal ... and self.scores.iter_mute cannot be called. I'll admit, don't know what that means. I'm gonna have to reread it. Sorry about this. I don't know what that means. Right, due to lifetime elision, the function getCurve has the type signature getCurve. Anything with a lifetime of a reference to a self of everything has the same lifetime. This means that a call to self.getCurve extends the entire borrow on self. Okay, so self.getCurve, which returns a reference, extends the entire borrow on self, not just on self.curve. So trying to utilize self.getCurve could extend the lifetime of the entirety of self. Why? And what's the error there? Therefore, self is immutably borrowed inside of the scope of let sum curve. Self.score.inner cannot be called. Self is immutably borrowed here because of lifetimes? Yes. Thank you, Sorbet. Yes. So that is because this is a reference to a piece of test results which is brought in here with self. So since this is passing back a reference to curve, everything else within curve and self itself would have to be immutably borrowed because curve is immutably borrowed. Okay. I'm never going to get that one. It's going to have to be pounded into my head. I'm okay with that, though. Thank you again for being here. Number 5, we got that one correct. I always hate the none of these programs option. It makes me scared. This program is actually safe as written. It is a limitation of the borrow checker to not understand that getCurve only borrows curve and doesn't affect scores. However, in theory, if getCurve were changed to return a reference to something with self.scores, then memory safety could potentially be violated. Okay. This one, we got correct too. So just returning curve instead of returning a reference to curve is the way to go. There was no reason to do that. By inlining the definition of getCurve into apply_curve, the borrow checker understands that self.curve is not self.scores. So it allows the function to compile. This is a common workaround for this type of borrow checker limitation. So getters are dangerous because the language doesn't understand them. That's what I've learned here. Getters are scary, and I am afraid of them. Another option is to leverage the fact that self.curve is cheap to copy and use self or options copied, which would release the borrow on self as soon as copied is called. Oh, okay. But that would allocate more memory, wouldn't it? But it's cheap. It's cheap to copy, but still costs us. Okay. Still. Oh god, testing. Oh no. My wolf's bane. I'm afraid now. Writing automated tests. In his 1972 essay, The Humble Programmer, Edgar W. Dijkstra said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. That doesn't mean we should try to test as much as we can. Correctness. Okay, so what he's just saying is that tests are great for showing bugs, but it doesn't prove that there are no bugs. Correctness in our programs is the extent to which our code does what we intend it to do. Rust is designed with a high degree of concern about the correctness of programs, where correctness is complex and not easy to prove. Rust type system shoulders a huge part of this burden, but the type system cannot catch everything. As such, Rust includes support for writing automated software tests. Say, we write a function add2 that adds 2 to whatever number passed to it. Function signature accepts an integer as a parameter and returns an integer as a result. When we implement and compile that function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we aren't passing a string value or an invalid reference to this function. Rust can't check that this function will do precisely what we intend, which is return the parameter plus 2 rather than, say, the parameter plus 10 or the parameter minus 50. That's where tests come in. That was a very good example. Yes, we do in fact need to test 2 plus 2. I'm glad that we've established that. We can write tests that assert, for example, that when we pass 3 to add2 function, the return value is 5. But what if they have an if statement? If 3, output 5, and they don't actually do the plus 2 on it? We better test every single number. We can run these tests whenever we make changes to our code to make sure any existing correct behavior has not changed. Testing is a complex skill. Although we can't cover every detail about how to write good tests in one chapter, we'll discuss these mechanics of Rust testing faculties. Talk about the annotations and macros available to you when writing your tests, default behavior and options provided for running your tests, and how to organize tests into unit tests and integration tests. Okay, good stuff. How to write a test. Tests are Rust functions that verify that non-test code is functioning in the expected manner. The bodies of test functions typically perform these 3 actions. Set up any needed data or state, run the code you want to test, assert the results are what you expect. Let's look at the features Rust provides specifically for writing tests that take these actions, which includes the test attribute, a few macros, and the should panic attribute. The anatomy of a test function. At its simplest, a test in Rust is a function that is annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the drive attribute we used in structs in chapter 5. To change a function into a test function, write hashtag, square bracket test, and square bracket, a line before function. When you run your test with the cargo test command, Rust builds the test runner binary that runs the annotated functions and reports on whether each function passes or fails. Whenever we make a new library project with cargo, a test module with a test function in it is automatically generated for us. This module gives you a template for writing your test so you don't have to look up the exact structure and syntax every time you want to start a new project. You can add as many additional test functions and as many test modules as you want. We'll explore some aspects of how tests work by experimenting with the template test before we actually test any code. Then we'll write some real-world tests that call the code that we've written and assert that its behavior is correct. Let's create a new library project called adder that will add 2 numbers. We are going to test 2 plus 2. That's good to see. Right. Let's do this. Cargo new adder -- lib cd into addr. Right. Let's go here. The contents of source lib. Yep. Should look like this. Let's check that. Maybe they're lying to us. No, they're not. Here it is. For now, let's ignore the top 2 lines and focus on the function. Okay, I don't know why that's there. Note that the test, sorry. Hello, Blorpuri. I think you've been in here before. I'm very glad to see you. Welcome in. We are currently learning about tests. You haven't missed much. Currently, we have just created a new test with cargo new adder -- lib in a new directory. We also crushed a test with 50%. We just passed, flying by the string of our pants, man. But we don't have to tell people that, honestly. Right. We are learning this, though. Welcome in. Glad you can join us. For now, let's ignore the top 2 lines and focus on the function. Note that the test annotation, this attribute indicates that the test is a function. That this is a test function. The test runner knows to treat this function as a test. You might also have non-test functions in the test module to help set up common scenarios. You skipped the test chapter? Oh no, well, I guess you're learning today. Non-tests in the test module. We can put non-tests in here to help us set up common scenarios or perform common operations. So we always need to indicate which functions are tests. Alright, so even if they are in like a test area, we can still add in random stuff to help us out without running each function as a test. The example function body uses the assert equal macro to assert that result, which contains the result of adding 2 and 2 equals 4. This assertion serves as an example of the format for an atypical test. Let's run it to see that this test passes. Alright, let's check. Does 2 plus 2 in fact equal 2? No, it equals 4. Wow, that's wild. I'm shocked, honestly. Right, yep, we got this output. Cargo compiled and ran the test. We see that the line running one test. Next line shows the name of the generated test function, called it works, and that the result of running the test is okay. The overall summary of test result, okay, means that all the tests passed. The portion that reads 1 passed, 0 failed, totals the numbers of tests that have passed or failed. It's possible to mark a test as ignored, so it doesn't run in a particular instance. We'll cover that in the ignoring some tests unless specified section later in this chapter. Because we haven't done that here, the summary shows 0 ignored. You can also pass an argument to the cargo test command to run only tests whose name matches a string. This is called filtering, and we'll cover that in the running a subset of tests by name section. We also haven't filtered the tests being run, so the end of the summary shows 0 filtered out. The 0 measured statistic is for benchmark tests that measure performance. Benchmark tests are, As of writing this, or as of this writing, only available in Nightly Rust. See the documentational benchmark test to learn more. I'm glad that they're making like a full-on benchmark testing suite. Usually we have to use third-party tools, but if the actual developers can make Rust seem like it's quicker than it is, then I can make my employer really like me. I'm kidding about that, honestly. They're probably going to do it perfectly accurately. You can trust the Rust Foundation. The next part of the test output, starting at the next part of the test output, starting at doc test ADDER, is for the result of any documentation tests. We don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. This feature helps your docs and your code in sync, keeps your doc and code in sync. That's really useful. I'm glad that exists. We'll discuss how to write documentation tests in the documentation comments as test chat section of chapter 14. For now, we'll ignore the doc-test output. Y'all gotta admit though, that is a really cool thing, that it can test the comments that you put in your code. Let's start to customize the test for our own needs. First, change the name of the It Works function to a different name, such as exploration, like so. Right? This feels satanic, honestly. Look, I'm from Shit Just Works. I hate taking this name out. It's like destroying my own culture, my own history. Exploration. Did I misspell it? I don't know. I can't read. Then run cargo test again. Yep. As you said, it's the name of the function. I'm not going to run it again. I think we understand it'll output the name of the function inside of here. I think we understand that. Now we'll add another test. This time, we'll make this test fail. Alright, let's just try this on our own. See if I can make a failing test all on my lonesome. Failure. Apparently we shouldn't have that. Assert. Equal. 0. And 1. That'll likely fail. Who knows though? Huh. Failure failed. Wow. Now we'll add another test, but this time we'll make a fail when something in the test function panics. Each test is run in a new thread, and when the main thread sees that a test thread has died, the test is marked as failed. Wonder why it uses panics instead of returning false or the like. Maybe it's my bias, but catching panics feels inefficient. Well, it's checking to see if something panics, if something will fail. Like assert equal. Well, actually, yeah, I guess so. Yeah, assert equal panicking instead of just passing back a false is inefficient. You're correct. I would agree. Perhaps either A, testing if it does panic, or B, testing if it passes back a false would be a better solution. That way the vast majority of tests will simply pass back true, or if they fail due to some just assertion being unequal and not an actual panic. Which, I mean, if the code compiles anyway, the panic shouldn't happen, right? So, yeah, I think you're entirely right. They should pass back a false instead of panicking. Talk about how the simplest way to panic is calling the panic macro. Enter the new test function named another, so your source lib.rs looks like listing 11.3. Assert equal, 2 plus 2 equals 4. Panic! Make this test fail. Oh, okay, they're just panicking instead of making it fail to assert equal. Run the test again using cargo test. The output should look like listing 11.4, which shows that our exploration test failed and another failed. Exploration test passed and another failed. Alright, let's see how this works if we do it the way they did. Test another, standard output, thread, test another, panic that make this test fail, source lib.rs, and 9. Versus this, which simply says, I don't know what that means. Oh, whatever. Assertion left equals right failed. There's nothing here. We haven't done that. I don't know what that means. Oh, yeah, I see. Yep, 0 does not equal 1. Yeah, that's the issue. Left, 0, right, 1. Sorry, I just thought. Yeah, I thought because that was that, it was for some reason running add. But no. Okay, whatever. Right, normally though, it'll just give you whatever panic output, tell you what failed, and give you all the failures. Instead of, okay, the line test, another shows failed. 2 new sections appear between the individual results and the summary. The first displays the detailed reason for each test failure. In this case, we get the detail that another failed because panic at make this test fail on line 10 in source lib.rs file. The next section lists just the names of all. Sorry, I didn't read that correctly. I got a text and wanted to look at it. In this case, we get the details for another fail because, yep, it panicked at line 10. The next section lists just the names of all the failing tests, which is useful when there are lots of tests and lots of detailed failing test output. We can use the names of failing tests to run just that test to more easily debug it. We'll talk about ways to run tests in the controlling how tests are run section. Summary line displays at the end overall, our test result is failed. We had 1 test pass and 1 test fail. Now that you've seen what the test results look like in different scenarios, let's look at some macros other than the panic macro that are useful in tests. Checking results with the assert macro. The assert macro, provided by the standard library, is useful when you want to ensure that some condition in a test evaluates to true. When we give the assert macro an argument that evaluates to a boolean. We give the assert macro an argument that evaluates to a boolean. Oh, yeah. If the value is true, nothing happens and the test fails. If the value is false, and as the assert macro calls panic, it would have been so easy to just mark the test as fail. To cause our test to fail, using the assert macro helps us check that our code is functioning in the way we intended. I wonder if panic just directly deletes everything to do with that function in that thread. Maybe panic actually is more efficient. I don't really know how the panic macro works. Perhaps instead of unwinding and correctly dereferencing our memory, it simply allows for the operating system to throw it away. Still though, I don't know about that. In Chapter 5, listing 515, we used a rectangle struct and a canHold method, which are repeated here in listing 11.5. Oh, here's another reason. What if we had, 12 assert equals? Like if we had 3 of these. If it's just passed back false, then all of these would still run, each passing back false until it hits the end. If this one passes back true, if this would say this, then there would be an issue. Because these are all false, which would pass it back. We'd have to carry this, let ants equal the output of assert equal. And then we'd have to check if that is failure at each point, and then break out of this function at each point. No, I do think that, in this case, panic might be the best, because it instantly stops the thread. You can just use an add-at chain? Yeah, but what if we had 30 different things that needed to be done in order to get the assert equal? Perhaps it's a large chain of different functions, if statements, for loops, etc. that need to be run in order to test the functionality of something. Or if it's something that can't simply be a list of add-at chains. Panic will, at any point in the code, instantly fail, instantly unravel, instantly kill the process. I mean, for simple things like just this, or something that could be put into an add-at chain, fine, that's perfectly okay. For it just to pass back a false value, and for the test to fail like that, but in any more complicated scenario, a panic will be the better solution. Sure, it'll be more inefficient in a place like this or in an add-at chain, but in anything much more complicated, it'll still work. I still argue that both should be available, but I'm glad that they have this by default. In Chapter 5, listing 515, we use a rectangle struct and a... using the assert macro helps us check that our code is functioning in the way we intend. Yep. In Chapter 5, listing 515, we used a rectangle struct and a canHold method, which are repeated here in listing 11-5. Let's put this code in the source live.rs file and write some tests for it using the assert macro. Right, we're just going to write this all in. I'm personally just going to copy it. Shouldn't do this, kids. We're trying to learn Rust. You should write it all out yourself, they'll tell you. And they're right. I'm a failure. Do not do as I do. Oh, that didn't work, did it? Now let's just delete this. We don't need it. Fields in the struct. Yes, there are fields in the struct. Fields width and height are never read. Yep, these are just warnings. Each assert is basically false, panic. So you can do the same with returns, to be honest. But I read up on it a bit, and maybe because it provides built-in stack traces. Ah, good point. Panic does, I mean. Yeah, that makes sense, too. Oh, yeah, I guess you're right. If the panic macro just... if false panics. Sorry, the assert macro just if false panics, then... yeah, you're right. Just passing back false would be kind of okay in that situation. Yeah, okay, yeah. That's a good point. Okay, yeah, this works. Alright. The canHold method returns a boolean, which means that we can... it's a perfect use case for the assert macro. In listing 11.6, we write a test that exercises the canHold method by creating a rectangle instance that has a width of 8 and a height of 7, and asserting that it can hold another rectangle instance that has a width of 5 and a height of 1. Alright, so in our test, we're going to create a new test. I'm going to delete failure. We have a function. Larger can hold. Larger can hold smaller. Inside of here, we are going to let larger equal rectangle. The width of 8 and a height of 1. Why did it do that? Honestly, I don't know. That's not supposed to be there. Yep, and that's there. Alright, then we will let smaller do the same thing. Oh. Will be 5. That's fine. And we simply assert larger and hold smaller. Passing in a reference to smaller. What? What's wrong? What's wrong? I don't understand what's wrong. Wait, I'm calling myself? Oh my god. Yep. Thank you. Larger dot. Yep. There we go. Thank you for that. I'm very tired, and my LSP hurt me there. Just a little bit. Thank you for the help. Okay. And I'm guessing if we test, it'll work fine. Cannot find add in this scope. What? Oh, yeah. I took add out, so... One failed. Okay, obviously I did not write this correctly. Somewhere I messed up. What's the issue? Panicked at source. Panicked at source live 28.9. Assertion failed. Larger dot can hold smaller. One with backtrace. I don't see the issue. Maybe the test module is a regular module that follows the user visually and paths referring to its module. Because test module is an inner module, we can... What? Did I mess up really bad? What have I done? Let's... Look, I know y'all are laughing at me. You all know I'm a fool. Oops. Okay, yeah, I did mess something up really badly. What did I mess up? What did I mess up? Can anybody see what I messed up? I can't. Sure can. We have let larger equal rectangle with a width. Can hold checks if width is bigger than 1 and length is bigger than 1. Width. One is equal to 1, it cannot count. Does this? Oh, that's 7. Okay, that's the issue. I thought 1 was 7, and I didn't read the original. This is why you should always write the code out yourself when doing this stuff. You save yourself time instead of actually... Thank you, Sorbet. Apologies, I blame being tired, but that was me just copying random code in and hoping it worked. And then not reading it at all. Alright, that is entirely my bad. Again, thank you for that. Note that we've added a... Right. Yep, this is where we were. Note that we've added a new line inside the test module, use super star. The test module is a regular module that follows the usual visibility rules we covered in Chapter 7 in the paths for referencing to an item, paths for referring to an item in the module tree section. Because the test module is an inner module, we need to bring the code under tests in the outer module into the scope of the inner module. We use a glob here, so anything we define in the outer module is available to this test module. We've named our test larger can hold smaller, and we've created the two rectangle instances that we need. And we call the assert macro, passed it the result of calling larger.canHold reference to smaller. This expression is supposed to return true, so our test should pass. Let's find out. Their test did pass, and mine do now. Because, well, let's check if it does. Honestly, it may just straight out not. Yeah, it passes. That's fine. Sick. It does pass. Let's add another test. This time asserting that a smaller rectangle cannot hold a larger rectangle. Right, so we're just going to assert the not of the original, I'm assuming. Test function, smaller, yeah, larger. Pretty simple. I'm just going to copy from here because what we are actually trying to copy is so what we're actually trying to do is not really relevant to hello this, so we're going to try and see smaller dot can hold. Why did that not work? Larger. Wow, really doing well today, and I swear I'm not like this when I'm coding in normal projects, but you know, maybe I'm lying to you guys. And we're trying to get the knot of this, right? Okay, thank you for that. Oh, yeah, I see. Asserts the macro, you fool. Yep, too fast. Because the result of can-hold function in this case is false, we need to negate that result before we pass it to the assert macro. As a result, our test will pass if can-hold returns false. To test that pass. Now let's see what happens to our test results when we introduce a bug in our code. We'll change the implementation of can-hold method by replacing the greater than sign with a lesser than sign when it compares the widths. Alright. And now it will fail, giving us the reason why it failed. What? Nope. Really? Wait, smaller cannot hold larger is okay. I guess so, yeah. I don't understand why. Oh, well, I guess because we didn't actually switch out both of these. I did not read this. No, that's exactly what they wanted. Right, chill, whatever. Yeah, apparently it's supposed to still go correctly. I haven't read that code again, and I'm not going to. I am a stubborn man. Our test caught the bug because larger dot width is 8 and smaller dot width is 5. The comparison of the widths in can hold now returns false. 8 is not less than 5. Testing equality with the assert underscore equal and assert underscore not equal macros. A common way to verify functionality is to test for equality between the results of the code under test and the value you expect the code to return. You could do this with the assert macro and passing in an expression using the double equals operator. However, this is such a common test that the standard library provides a pair of macros, assert equal and assert not equal, to perform this test more conveniently. These macros compare two arguments for equality and inequality, respectively. They also print the two values if the assertion fails, which makes it easier to see why the test failed. That's good. Conversely, the assert macro only indicates that it got a false value for the double equal operation, without printing the value that led to a false value. In listing 11.7, we write a function named add2 that adds 2 to its parameter. Then we test this function using the assert equal macro. Right, yep, we just have this, which adds 2. We assert it adds 2. We have assert equal 4, add 2, 2. So we just add 2 to 2, which passes back 4. 4 equals 4. Hey, let's go. Let's check that it passes. Yep, it passes. I'm going to assume it passes. You don't need to see me fail to be able to see if 2 plus 2 equals 4. I'm scared of that. We passed 4 as the argument to assert equal, which is equal to the result of calling add 2, 2. The line for this test is tests, it adds underscore 2, ... okay. And the okay text indicates that our test passes. Let's introduce a bug into our code and see what assert equal will look like when it fails. Change the implementation of the add2 function to add3. Right, yep, and it will fail. Really, I don't think that we need to do this ourselves. I think we can really understand that assert equal is going to do exactly as it states. But I'm really curious about the output, which we did see earlier when I checked. Right then, panicked that assertion failed. Left equals right. Left equals 4, right equals 5. No, run with Rust backtrace. Yep, let's see the full backtrace. Right, so it'll always say left and right here. I guess that's what the values are called inside of the macro. Our test got the bug, and it adds 2, test failed. The message tells us that the assertion that fails was assertion failed, left equals right. And what the left and right values are. The message helps us start debugging. The left argument was 4. But the right argument, where we had add 2, was 5. You can imagine that this would be especially helpful when we have a lot of tests going on. Note that in some languages and test frameworks, the parameters to equality assertion functions are called expected and actual. And the order in which we specify the arguments matters. However, in Rust, they're not called that, and they're called left and right. And the order in which we specify the values we expect and the value the code produces doesn't matter. We could write the assertion in this test as assert equals add2, 4, which would result in the same failure message that displays assertion failed, left equals right. The assert not equal macro will pass if the two values we give it are not equal and fail if they are equal. The macro is most useful for cases where we're not sure what a value will be, but we know what a value definitely should not be. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we run our tests, the best thing to assert might be that the output of the function is not equal to the input. Under the surface, the assert equal and assert not equal macros use the operators equal and not equal respectively. When the assertion fails, these macros print their arguments using debug formatting. Yep. Sorry, what? Which means the values being compared must implement the partial ec and debug trait. All primitive types and most of the standard library provide implementations of those traits. For structs and enums that you define yourself, you'll need to implement partial ec to assert equality of those types. You'll also need to implement debug to print the values when the assertion fails, because both traits are derivable traits, as mentioned in listing 512 in chapter 5. This is usually as straightforward as adding the derive, partial equal, and debug annotation to your struct or enum definitions, the appendix C, derivable traits. Apologies. For more details about these and other derivable traits. You can also add a custom message to be printed with the failure message, optional arguments to the assert equal, and assert not equal macros. Any arguments specified after the required arguments are passed along to the format macro discussed in chapter 8 in the concatenation with the plus operator or the format macro section. So you can pass a format string that contains blank placeholders and values to go in those placeholders. Custom messages are useful for documenting what an assertion means when a test fails. You'll have a better idea of what the problem is with the code. For example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. We have a public function, greetings, taking in a name, which is a reference string slice, returning a string. Formatting, hello, just putting in the name. We have the test module using super, all, a function, greetings contain, name, let result equal, greetings, Carol. Assert, result that contains Carol. That's true if it has Carol. Requirements for this program haven't been agreed upon yet, and we're pretty sure the hello text at the beginning of the greeting will change. We decided we don't want to have to update the test when the requirements change, so instead of checking for the exact quality of the value returned from the greeting function, we'll just assert that the output contains the text of the input parameter. Now let's introduce a bug to this code by changing greeting to exclude name and see what the default test failure looks like. Right, yep, greeting just passes it, hello! It compiles, fails, yep, fails here. Thread, test, greeting contains name, panic at assertion, failed. Result contains Carol. In source, lib.rs. Yep. So since it's just assert, it's saying that no, it does not include Carol. This result just indicates that the assertion failed, and which line the assertion is on. A more useful failure message would print the value from the greetings function. Let's add a custom failure message composed of a format string with a placeholder, filled in with the actual value we got from the greetings function. Right, so we have the assert, which asserts result.contains Carol, which will put out a binary, and if that fails, it has greetings did not contain name, value was. This is the format string. And then we have the value to put inside of the format string. Now, when we run the test, we'll get more informative error messages. Right? Red, test, greetings, name, panic attack, greeting. Did not contain name. Value was hello. No, run with Rust backtrace. Yep, we get that. We can see the value we actually got from the test output, which would help us debug what actually happened instead of what we were expecting to happen. Okay. So we should probably always do this type of thing, and anything that could fail in a way which isn't noticeable, and anything which we can't exactly utilize assert equals with. We can see the value we actually got in the test output, which would help us debug what happens instead of what we were expecting to happen. Checking for panic should underscore panic. In addition to checking return values, it is important to check that our code handles error conditions as we expect. For example, consider the guess type that we created in Chapter 9, listing 913. Other code that uses guess depends on the guarantee that guess instances will contain only values between 1 and 100. You can write a test that ensures that attempting to create a guess instance with a value outside that range panics. We do this by adding the attribute should panic to our test function. The test passes if the code inside the function panics. The test fails if the code inside the function doesn't panic. Okay. Shows a test that checks that the error condition of guess new happens when we expect them to. We have a struct called guess, which is a value which is 932, implementing guess as a public function new, returning a guess. If value is less than 1 or value is greater than 100, we panic. Got a value outside of that range. Guess value. Otherwise, we just return the guess with the value inside it. The test, which is annotated with should panic here, it's just a function that guesses something outside of the original range, called greater than 100. Alright, that's really cool to see that this exists. Wonder how far we can push this, how many annotations we can have. 40, 50, 80? You place the should panic attribute after the test attribute and before the test function it applies to. Let's look at the result when this test passes. Cargo, test. Right. It's just okay. We see nothing unique, I don't think. Yeah, that looks like the same thing. Looks good. Now let's introduce a bug in our code by removing the condition that the new function will panic if the value is greater than 100. Alright, this will no longer panic if it's over 100, meaning that this fails. Alright, tests greater than 100, should panic, failed. I'm glad that it puts the should panic in there. Failures. Note, test did not panic as expected. Failures. Here's the failure. One failed. We don't get a very helpful message in this case, but when we look at the test function, we see that it's annotated with should panic. The failure we got means that the code in the test function did not cause a panic. Also is said right here, should panic. Good. Tests that use should panic can be imprecise. A should panic test would pass even if the test panics for a different reason from the one we were expecting. To make sure should panic tests are more precise, we can add an optional expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guess in listing 11-9, where the new function panics with different messages depending on whether the value is too small or too large. Alright, so we have implement guess, function new, yep. Value is less than 1, panic. Value is more than 100, panic. Both panic, passing back the value inside of this text. Alright, we have a test. Should panic expected less or equal to 100. So this is just expecting text to be equal to exactly, expect something within it. So this is just expecting that a substring exists where it says something like this. Okay. The test will pass because the value we put in the should panic attribute expected parameter is a substring of the message that the guess new function panics with. Okay, yeah, so this just checks for a substring. We could have specified the entire panic message that we expect, which in this case would be guess value must be less than or equal to 100, got 200. What you choose to specify depends on how much of the panic message is unique or dynamic, and how precise you want to be in your test. In this case, a substring of the panic message is enough to ensure that the code in the test function executes if the if-else fails, if it's over 100 case. See what happens when a should panic test with an expected message fails. Let's again introduce a bug into our code by swapping the bodies of the if value and the else value blocks. Yep. If it's less than 1, guess value must be less than or equal to 100. Got, Lord knows, what value. Else, yep. This time, when we run should panic, the test fails. Should panic fails. Yep. No, run with. Where's the here, I guess? Right, so this is the original panic, and here is the note. Panic did not contain expected string. Panic message. Guess value must be greater than or equal to 1. Got 200. Expected substring. Less than or equal to 100. Alright, yep. The failure message indicates that the test did indeed panic as we expected, but the panic message did not include the substring here. The panic message that we did get in this case was guess value was greater than or equal to 1. Must be, yeah, we got 200. Yeah, it must be greater than or equal to 1, whereas we want it less than or equal to 100. Now we can start figuring out where our bug is. Alright, using result TE in tests. Sorry, this is just a lot of information, and it doesn't. It's I'm just running through this. Apologies for that. It looks like we lost buggery. I feel bad about that. Our tests so far all panic when they fail. We can also write tests that use result TE. Here's the test from listing 11.1, rewritten to use result TE, and return an error instead of panicking. Make tests, module tests, tests. Function, it works, yep. If 2 plus 2 equals 4, okay, else, error. 2 plus 2 does not equal 4. The it works function now has the result string return type. Yep. in the body of the function. Rather than calling the assert equal macro, we return OK. When the test passes, and an error with a string inside when the test fails. Writing tests so they return a result enables you to use the question mark operator in the body of tests, which can be a convenient way to write tests that should fail if any operation within them returns an error variant. You can't use the should panic annotation on tests that use result DE to assert that an operation returns an error variant. Don't use the question mark operator on the result TE value. Instead, use assert equal value is error. Okay? Oh, sorry, that's just assert, not assert equal. Sorry. Now that you know several ways to write tests, let's look at what is happening when we run our tests and explore the different options we can use with cargo tests. What is the annotation you add to a function to indicate that it is a unit test? Specifically, a unit test? Well, we've been doing unit tests the entire time. So that would be test. It is a test. Let's say you have a function with the type signature, function f in x, which is usize, returning result, which is use of usize string. You want to test that f0 should return error. Which of the following is not a valid way to test that? Alright? So we're returning a result usize string. We can't do that. Apparently that's not a thing we should do. Right? Should panic f.unwrap. If that's an error, it will panic, I believe. Assert f.0 is error. That'll be true. If it is an error, that'll be true, and that test will pass. Test assert. What? Let's say you have a function with the type signature and you want to test if f0 should return error. Which of the following is not a valid signature? Yep, so this is fine. This is perfectly okay. We have assert, match f0, okay, returning false, error, returning true. And if it's an error, it will return true, assault will be true, it'll pass. Right, f.unwrap will panic if that is an error, I guess? Yeah, it'll panic if that's an error. Yeah, this is the one which we don't use. Okay. 2 of 2 questions are correct. Read the context. This informs the cargo testing harness to treat the function as a test and not a library code. Not library code. Should error does not exist in Rust. Oh. Yeah. Any test that returns a result must return OK to pass. Okay. Again, sorry for running through that last little bit. I appreciate y'all being here, but I think that's about it for tonight. I did learn a bit about testing, but really, there's not too much we've discussed here. We're probably going to get a bit more into it under here and here. This is what I'm a bit excited for. Assert and assert equals and assert not equals are pretty common things. Again, apologies for running through as quickly as I had. Next week, though, we are going to be getting through controlling how tests are run and test organization. Thank you all for being here, though. But this is going to be it for me tonight. Good night. Farewell.